So this is Skeleton. I'm Colin Rice. Someone say their name.
I'm Shane.
Sam.
Body.
I'm Kate.
Okay. Yeah. So we're just going to do sort of a quick status update plus an explanation. So how many people here have heard this what is skeleton presentation before? How many people have never heard this? Okay, so this might help. So the idea behind skeleton is you've got some server software, you want to deploy it, and if you try and do it now, it's sort of a giant mess and it's tricky. So the idea is that we can describe what you want with something like this. It's a simple config file. You say, hey, look, there's these 4 machines, and I want to deploy this hello container on them. And specifically, I want 1 hello container on each machine. And that's all you have to do. And then you run it, and it does a bunch of stuff. And you've got your deployed system. There's a couple like sort of general components to this that will help make these guys' talks a little more understandable. So like there's this idea of gatekeeper. So it's just this server that is designed to be like a central storage of information for the deployment. So like it knows where everything is. It can build access information that like will tell your web server where your database server is and what its password is, but it won't tell like your memcache server, right? Because the memcache server doesn't even know that database server. It's also supposed to persist deployments. In reality, what it does right now is it actually doesn't pass its own unit test because I wrote those about an hour ago. It does come up. It can't remember any data, like it persists no data to disk, so every time you restart it, it loses its entire line. I'm pretty sure it's not storing information because that's the thing I started unit testing and everything broke. And it stores absolutely no ideas about any containers that are deployed. But it has goals. So people are just going to talk about what they've done. I don't know how much that is. I think that's fair to say.
So I've really done a lot of work on the calc update, but right now, it just, it gets like the IP name and that goes with those IPs, and then it tries to deploy like an updated one, and that's about it. But in the future, I'm going to add that way you can do like multiples and have like quantity as well as granularity. So you can say how many you want per machine and how many you want going stuff.
Okay, yeah. So basically, I'm just trying to work to fix a message output and and fixing how the errors. So trying to wrap like messages and errors together into one like channel. So if we like put them together instead of just sending errors and sending messages and send the error messages directly.
You done?
Yeah.
So I did Tartar. It's pretty straightforward. It does what it sounds like. It takes in a string for a file directory and tars up all the directories, presses them down. It's used mainly when deploying images and creating images to be pushed to all the containers. Split up into, it's a basic recursive function. It replaces a previous implementation that only hit the first level directory. So if you slide one more. This is the helper function that gets all the information about the file headers and the file content and pushes them back to the previous function, which then puts them all to our file, which is sent back to one place.
Alright, so I just added some here basic flags and arguments that it takes in because we don't want everything deploying to all containers every time we run it. There's a basic deploy command, which does deploy everything. There's a version, just so you know which version does. There's update gatekeeper and orchestrator, so it updates those 2 things. And there's also a push container, so it pushes to a certain container specific to that, as well as decode.
So I mostly worked on figuring the upper functions. So previously, these functions were mostly just passing strings everywhere, and that made it really messy to work with. And basically, we wrote them as methods with those structs up there, and now it should be totally easier to do.
So that's skeleton. Okay. Thanks to RCOS, Sean Sullivan, Professor Morton, and Professor Goldschmidt. Are there any questions? Okay. So now this is probably going to work because you're going to ask a question and then I'm going to look confused and someone in this group will answer it. Okay. So. Oh, I can answer that. It's written in Go. Which is like a modern C from Google with a bunch of other stuff.
a lot of other stuff.
like channels and currency and all this other things.
We're at Target. You should look up the path package, which lets you combine paths automatically for like a bunch of stuff.
Yeah, that would make sense.
Some slashes everywhere.
Yeah.
Path.
How are you handling password communication to make sure that nobody like intercepts it?
I guess this is my question. So right now, there is no password communication, so there's no worry about interception. In reality, the plan is that how this is all going to work is it's HTTP communication between all the nodes, and we can actually set up certificates on Orchestrator and Gatekeeper that represent each of them uniquely. So essentially, what's going to happen is you'll send your password over a TLS connection that's actually been hard coded to only allow one specific certificate on one specific machine, and we'll store those client sites sort of like how SSH does with known hosts. So that's what it's going to use. In reality, we haven't done any of that yet. So it turns out the Go TLS implementation was to 1.0, and I want to use 1.2, so I'm going to think about wrapping OpenSSL into Go, but that's a large project that I want to assign to someone else. Like Shane might do that. So that's the plan. Any other questions?
What do you have planned for the latter half of the semester? What do you do with
So some of that stuff is still in progress. Some of it's not as much. So the message passing is pretty much done. He's probably going to jump on too. So what happens when you do a deployment is Gatekeeper streams, Orchestrator streams back a lot of debug info, but there's some stuff it doesn't stream back. So he's going to basically like go into our logging infrastructure and allow you to have like split logs. So both logging to Orchestrator log output and any connection to Orchestrator that should see the log output. So you can be like, hey, why haven't I deployed in the last 10 minutes? Oh, I'm downloading the 5 weeks of data. That explains a lot. So that's that plan. Shane right now is trying to fix a bug in why we don't actually deploy anything successfully. And then what's going to happen basically is Gatekeeper is almost to the point where it's usable, and so then someone's going to get assigned to working on storing logs. Someone's going to where is he? Status page. Yeah, he's actually working with this too, and just wasn't at the Sunday meeting, didn't come up, and I forgot to yell at him to come up. But he's going to be working on the status page. So someone's working on logs, someone's working on status page. Someone's actually working in like actually using Gatekeeper to link everything together with passwords. Someone will probably be working on firewalls. I think I have one more person, and I don't know what I'm going to assign them to yet. But that's the plan. Any other questions? By the way, we're done.